Hi everyone, I'm Varsha Saha. For those of you who don't know me, I work at Flipkart. I'm an engineering manager at Flipkart. And today I'm going to talk about shipping code faster. My request to the volunteers, please don't show me the time card. I might extend a bit. If you're all bored, you can just raise your hands and say, hey, we are bored. Yes, let's start this. Is the glare a lot? So sorry, I have made a white background slide. And people at the back, are you able to hear me? Okay. I hope people who are watching me from YouTube are also able to hear me because we saw some technical glitches. I hope that's fixed now. Back in 2018, Flipkart chose to move to React Native and React Native Web for all our mobile channels, which is Android, iOS, and Web, and Insight. Our desktop still remained with React code base because we did not know how RNW would actually perform on web. For 3 years, 4 years, we've been working with React Native and React Native Web for these channels. And these are the viewports that we support right now. The problem when we dived into React Native and React Native Web is a plethora of developers from different streams, Android, iOS, Web, they all started coding into one code base. They all started coding, they all started creating their widgets, and this is how it went. So say a developer had created a widget, the second developer, if they had to write a text line below something in the widget, they created another copy of that widget. So that's the first problem. Problem of too much. The problem of too much code, too many widgets, copies, and their copies. How many of you can relate to this? Okay, few of you, good to know. So this was a major problem. For every extension that we were doing, we were creating similar copies of these widgets. A lot of code being bundled, a lot of code being shared. This is the snapshot of the actual repository, and I am sorry for my developers at Flipkart. But if you see, all of this points to one single widget, which is something called as PMU that we use, right? And this is just half the screenshot. Imagine the amount of variations of PMUs we've created in our code base. This is problem number one, right? There are so many copies of PMU. Today, if I ask any of you that, hey, I want to extend PMU widget by one title, which file would you choose? You wouldn't know. In this state, the only way to code faster is to create your own file and widget. You'll go ahead and create your own file and widget because you wouldn't know which file to change, right? Unless some legacy developer is there and you want to ask them, you wouldn't know which file to change. The worst fear of an engineering manager then is having a one-on-one with their team and engineers complaining about creating only widgets. What is my growth path? Where do I go from there? Right? This is my worst fear. Problem number two, the problem of designers hating engineers. By the laughs that I'm getting, I'm thinking all of you can relate to this. How many designers in the group right now? Oh, good, saved. This is the second problem that I'm talking about, right? There's no design coherency with us, with 4 channels, even with the single code base, but you've seen the copies that we've created, right? None of our developers or none of the developer team goes to the designer to take the sign off for the coherency of the design, right? And which is where this battle happens. In this state, the only way to code faster is to say, hey, designer, let's just, I'm going to push to production anyway. In this state, the only way to code faster is to shake off the fight and push to production, which is what most of us do, right? Not wait for the design sign-off. The worst fear of a designer is bad design in multiple places and people calling them out on Twitter and LinkedIn. They get tagged a lot. Flipkart UX sucks. What is Flipkart designer doing? Look at this widget, right? That is their worst nightmare come true. Problem number 3 is the problem of screen sizes and a collective laziness from the developer, from the engineering manager, and from your product managers. Now we do have one code base, but we said, okay, let's do it for the mobile version. Who is actually going to create separate widgets for desktop, right? Not me. During BBD last year, we had 200 features, over 200 features being released. Imagine doing 200 feature work on 3 channels and then +1 on desktop. You're not overpaid, right? In this state, the only way to code faster is to not code for one channel at all, which is what happened. We left our desktop as a channel. We left it long back. I think the last code that would have gone into desktop would be somewhere around 2016 or 2017. It's that old. The worst fear as a web engineering manager is engineers saying we are not focusing on web anymore, right? Which is the worst state for a web engineering manager. To recap, what we want to focus on is removing redundancy in feature creation, which is we want to bring parity across channels, but still not have the 10,000 files that I listed down. Have a coherent design across platforms so that the designers are not at our backs, and of course, are not getting abused all over social media platforms. It should also be compatible with all screen sizes and platforms while maintaining platform capabilities. When we moved to R&W, our worst fear was losing web capabilities. And by the way, that did happen. Our vital stand, rest of the things that we could have potentially done better using web fundamentals, we did not do it because we put agility over everything else, right? And that's not the right state to be in either. Whatever tech stack that you use, the platform capabilities should still be top-notch. And last but not the least, we wouldn't want our developers to create 400 different widgets for 4 different platforms. We wanted to maintain the same agility. And that's where we developed this low-code platform. The idea is to bring one widget capability to all channels without additional effort. This is what the low-code platform is all about. And our team has been working for the last 1.5 years on this platform to bring to all the developers in the Flipkart group to have more coherency in design and to not code every single time. Before I get into the technical details of this project, I would also like to bring the design fundamentals that we had in mind. As I said, we wanted to cater to a large sort of devices. How many of you have foldables right now? Foldable phones, flip phones, okay? You know the problem with foldables, right? The apps look horrendous. The UX is horrendous, right? Unless somebody is good enough to do that. We also wanted to support futuristic devices like foldables. I'm sorry for showing this slide. I've got a lot of flack for it on Twitter. Hence, I've moved to Threads. So those of you who want to follow me without bashing me, please move to Threads. If a snake was responsive, would it look like picture A or picture B? Engineering manager doesn't code. It could be any question. It's a UX question. As a consumer, what would you like to see, A or B? A, right? B is like the lazy option. Talking about the design, we had a UI palette. We had a palette of design that we already were using for Flipkart.com. And we stuck to that palette itself. We have a lot of design tokens, a tonal palette here, which also supports warning codes, error codes, background color, and stuff like that. All this coming from our design team. We also had a type scale. And I think Kamlesh is the better one to talk about these design tokens. But our designers also did a lot of research in the background to come up with the right system tokens. So if you say default FK font title, it will scale to different platforms and different viewports seamlessly. If it is a 16 pixel on mobile, it could be an 18 pixel on medium devices like tablets, and it could be a 24 pixel on larger devices like desktop. So everybody else is abstracted out of these, writing pixel-based code anywhere, right? You just use the design token and it auto-scales. Our designers went ahead and created a responsive design framework and a custom grid. And this is where I would like to pay, for you to pay more attention, because the subsequent slides and the subsequent things that I'm going to be talking about will be based on this responsive grid. So we tried to divide it into small devices, medium devices, and then larger devices. Doing an industry research, they came up with a tablet which is 767 pixel, which would be the last threshold for your small device. And then your medium device starts, and then your large device starts, post 1191 pixels. In the smaller devices, or in the medium or in the large devices, you will see a call span of 12, right? So we divided the screen into 12 columns. But the width of each column differs as the size progresses. So medium-sized devices will have a different call span width as compared to the large or as compared to the small. As I was saying, we've divided our screens into these grids. Design of each widget. Now this is the first time a website in the country has done so. Most of the websites follow the B part of the snake, right? And even if they do follow the A part, the code base is not low code, the code base is not a single code base. We actually developed a shapeshifter website. And the design has used principles like reposition, resize, reflow, show hide, replace, and re-architect. Just for an example, this is the console that we had built, and I'll come to the console later. But if you look at this, this is how the widget looks in small, this is how the widget looks in medium, and this is how the widget looks in large screen. So if you see, it is not the B snake that we have done, it is the A snake that we have done. On a smaller screen, this particular widget takes a 2x2. On a medium screen, it takes a 1x4. And on a larger screen, it again takes a 2x2, but it can be grouped with other 2x2, right? So this is how we've done things. We've shape-shifted and not necessarily stretched things to make them responsive. Let's talk about the thing that I showed on the video itself in a more picturesque format. Let's forget the hide category group part of it right now and talk only about the column span. And this is just one example of the widgets. A lot of other widgets are being created like this. So if you see this suggested for you widget, on a mobile of 360 pixel, it is a 2x2. On a 480 pixel, it is again 2x2. And then the threshold where we reach the smaller device, it's still 2x2, but with margins, right? So it takes full width. And these are the definitions that the designer has given us for all the widgets that we've created. In the tablet, the same widget again takes full width, but it looks very different. It's not a 2x2 anymore. It is a 1x4. Sorry, it's not a 2x2 anymore. It's a 1x4. On the desktop again, the call span changes. Now it is not full width. If you see, it's 4x12 here, which means that the rest of the 8 columns can be occupied by other widgets. Before I talk about this, I think this is pretty clear, right? So if widgets are vertically aligned till now, and I suddenly want my horizontal spaces to fill, this is how I'd do it, right? This is how I'd group things. Talking about the low-code platform, as the designers had already given us design tokens, we started creating them and we started incorporating them into our platform. So we have design tokens like spacing or colors, like primary colors. We have atoms, we have buttons, labels, images, row, column, box. We also have complicated atoms like carousels, right? So it's not just simplistic atoms, it is also other atoms like carousels. Using these atoms together, we create widgets. How are widgets created? That's where our what you see is what you get editor plays a role. And our team did a lot of research on what is the best editor. So this is a drag and drop editor where anyone can drag these atoms and create a widget, right? So you are not writing any code anymore. Anyone, from your designer to your product manager to even a developer, can drag and drop these atoms together to form a widget, right? And on the right side of it, you can see that we have put all the design tokens that the designers had given us. So you're abstracted out of 12 pixel, 16 pixel, color background red or something like that, right? It's all tokens that are there in our WYSIWYG editor. As I've mentioned in the slide as well, the input and the output to this editor is a DSL, right? This is how our editor looks like. There's a sidebar which contains all these atoms that can be dragged and dropped on the layout in the center screen. We have access control options here, and we have the tokens that our designers gave us, so you can choose. If you notice something, we have mobile, we have tablet, and we have desktop icons on the top right side of it. When you drag and drop a widget, it will also show you how it looks like on a medium screen or a large screen, right? So all three screens covered, all channels covered, just by drag and drop and generating a DSL. Nobody has written any code till now. This is how the DSL looks like, typically, with the type, right? Some children and the tokens. This is what this whole console, when you create a widget, a DSL like this gets generated. And then it gets saved into our database. We have a widget service database where all of these DSLs go and get saved. When I say low code and no code, there's a difference, right? Since we are spitting out a DSL out of our widget builder, we had to write only this piece of code in our coding repositories, whether it was for desktop, whether it was for Insight, whether it was for Android or iOS. This is the piece of code that we've written to convert this DSL into a React element. That is how it is a low-code platform. Somebody asked me for an HLD on Twitter. So here's the HLD. We have a component library, which we call as Fig UI. It has all the atoms that I just spoke about. You drag and drop these atoms onto the D&D console, the drag and drop console, which generates a DSL. Once this DSL is generated, it gets stored. And our backend server then combines the data and the DSL together and fetches it for the client. The only code the developers will be writing is here, the widget builder or the business logic, not the code for the widgets. Coming to the web part of it now, we call this one view because it is one view. We are not creating separate code for separate viewports or even channels. We try to use layouts and atoms, a combination of React and CSS, and business logic in the shared R&W repository. As I mentioned in the beginning of the talk, we had migrated to React Native Web. But the performance of React Native Web, for us, was not that good. So we switched back to our basics. We tried using more CSS. This carousel right here, developed by one of my peers, is a pure CSS carousel. We tried to use semantic HTML wherever possible. A lot of CSS properties in our core components, animations and other interactions. And for images, of course, because it will stretch on different screen sizes, we had the aspect ratio support. Remember I spoke about problem 3, the problem of screen sizes and def, PM, EM laziness. Basically, I want to put these widgets on every screen and not have to create separate widgets for a larger or a medium screen. Before I get to how we did it, there's a history of how Flipkart.com works. We have people in the team who configure a page like this for you on sale days, on normal days, they configure a page. They say, hey, slot 1 belongs to this data provider. Slot 2 belongs to this data provider. Slot 3 belongs to C data provider. And it can change based on your normal days, based on your sale days. Somebody can take slot 1, ads team can take slot 2. It is all dynamic in nature. Right? Again, we are talking about migrating these widgets from a more vertical viewport to a horizontal viewport. Right? So we have to do some sort of grouping, right, on a more horizontal viewport. If these vertically stacked widgets are supposed to come, we don't want to leave white spaces and we don't want to stretch, as I said. So we want to group widgets together. Why we couldn't group widgets together at this layer is because we don't know which data provider will take slot 1 or slot 3. It's all dynamic in nature, right? And we don't even know at runtime whether a widget like this will come or whether a widget like that will come. It is totally undecided. So we couldn't keep a grouping logic here that, hey, if it looks like this on a mobile viewport, how will it look like on a larger viewport like desktop? We couldn't do this here. Hence, we did it on the client. If you see, this is a screenshot from a real production. If the widgets look like this here, they're grouped together on desktop. And all of this is being done on our side. Our framework takes care of it. Nobody has to write any code for this. Ops doesn't have to configure anything for this. This is all done automatically. This is all auto-generated code. How did we do this grouping logic though? Right? Moving from a more vertical screen to a more horizontal screen. What we tried to do is bucketization. Remember a few slides ago I was saying don't pay attention to the height category? Well, this is the time to pay attention to a height category. Why height category? A widget can be this small, a widget can be this big. When we are on a mobile viewport, it doesn't matter because it is all vertically stacked. When we move to a larger viewport, imagine grouping this small a widget with this big a widget. There will be a white space left, right, on a particular row. And we did not want that to happen. So every time someone creates a widget on the console that I showed, we do a height categorization. It is small, medium, and large, right? And they have a range of heights within them. So small can range from 20 pixel to 50 pixel. A medium can range from 51 pixel to 80 pixel, and so on. What happens when the similar grouping widgets are clubbed together? We use flex to fill in the leftover white spaces. But it is very less in comparison to what we could have done if we placed very mismatched height widgets together on a horizontal viewport. So it still looks seamless because we had grouped the widget into the right category. And this is the algorithm that we used. So let's say if slot 1 has 6 calls, slot 2 has 12 calls, and slot 3 is using 6 calls again, slot 1 will try to fill in the remaining space with the best fit, which could be a 6-call span or a 2-3 call span. If nothing is available, that can also be the case, by the way. Because it is mobile viewport, you see the widgets tagged. On a horizontal viewport, what if small did not match with any of the widgets that were there? In that case, we start filling the space with so-called fillers. And these fillers will be used or can be used by any ads or any other merchandising or any other product that wants to use that space. The time complexity of this algorithm is O(n), and this is the real execution time of this algorithm we have measured. So even on the client, even with this automated grouping logic that we have, the execution time doesn't exceed 0.29 milliseconds. So it is as fast as it can be. And this is a visual representation of how it looks like on the medium and the large screen. Look at it. On the medium screen, it could not find one widget, so it placed one filler on one row. On the larger screen, it could not find two matching widgets, so it put two fillers on the two rows. And this is just a small GIF that the team has created to show you how the grouping works between mobile and desktop. The remaining space is filled by fillers. Other enhancements that we did when we did OneView was using semantic tags and links. It is much more SEO friendly. Google has shifted its indexing from desktop to mobile, and we are ensuring that we can be as SEO friendly as possible. With RNW, we had also adopted recycler list view, which is a virtualization technique for longer lists. The biggest drawback of a recycler list view is that it uses hard-coded height and widths, and we did not want that for our responsiveness. So we removed the RLV altogether and replaced it with a web solution. We also use CSS grids and a lot of CSS and JS, Dan.js, for any animations and transformations. And that is how our website is performant right now. In the future releases, because this framework is almost ready, we will be supporting apps with adaptiveness. We will also be bringing tablets and foldables into picture, and it will also have a better landscape mode support. This is the widget console where people drag and drop widgets to create, drag and drop atoms to create a widget. It spits out a DSL, sends it over to the widget service within 5 to 7 minutes. The API server collects this widget data and renders it to all the channels. Apps, M-Site, web, with the rule engine that I spoke about. This is the code that our developers are writing. And as you can see, there is absolutely no deployment needed here unless we change something in the business logic. That is why it is a low-code platform. Everything happens between 5 to 7 minutes, and you don't have to do anything. This is the right way to code faster. And I'm going to show you Flipkart.com in production. This is how it looks. These are all the widgets that are there on mobile itself. If you see here, it tried to group something, but it could not find the right grouping or the right widgets. We've put an ad there. It's a filler. On another portion of it, we were able to put all these categorization of widgets together, so they are together. And this is how the entire website functions. This is no code. We have not changed anything. This is auto-generated with the rule engine and with whatever the ops people are configuring. We have not written any code for this. I'm also going to show you this is our tablet view, rendered automatically. If you notice, the fillers have gone, because in the medium screen, it is able to group the widgets as it wanted to, and there was no need for fillers. And yet again, if I do this, back to mobile view, same widgets, no change, no code, low code, just atoms. Thank you.